Okay, so next up is Zach. He is the Chief Product Officer at AMI. Also, he's the open source Center of Excellence leader at AMI. So hand it over to Zach.
Hello. Good to see everybody. Pretty good turnout so far. A few people still coming in. Again, thanks, Brian. Definitely thanks to Meta for hosting this and really helping us bring the community together. So you all probably have heard of AMI, and in the OpenBMC community or open source community may have thought different things of AMI over the years, right? So I want to help explain how AMI is shifting on open source, what we're doing in contributing, and how we are trying to make the community better and improve everything that's going on within it. So first is our promise. We have a free, pure open source BMC based upon the Linux Foundation. It's one management stack that has merged changes from a number of these forks that Patrick talked about. We're trying to kind of herd these forks all back into something that's common. And it is highly customizable. So people who may have used AMI source code historically know that we put hooks in there. We've done things to make it highly customized. We're doing the same thing here. And it's community driven for third-party innovation. So we are also allowing third parties to help us improve this stack overall. So one of the key challenges is definitely what Patrick talked about, is there are over 15 relevant forks out there today in the OpenBMC community. And most of these tend to be driven by either SoC vendors for BMCs or host silicon from different hardware vendors as well. So I put it on the bottom here. If you were a company using Intel, AMD, NVIDIA, ASPEED, and Nuvoton, you basically now have to have teams working on a number of different code bases here. I've got 8 teams. They're all using different OpenBMC versions, which have different kernel versions, different U-boot versions, and everything behind this. And it's very difficult for you to manage as you scale out that direction. So what we've done is we're pulling from all of these different forks and merging them back into a common tree that we're validating across these different silicons backwards and forwards. And this is what we are contributing back to the community. So why aren't we doing this in OpenBMC itself? We are. So we'll talk about that in a minute. But basically, as Patrick talked about, OpenBMC does have its own cadence and its own development cycle, and we are committed to upstreaming everything we do. But at the same time, for validation, releasing, and testing purposes, we have this parallel tree that we're basically creating an OpenBMC distribution from more than anything else. So we'll talk about more about this as we go into each one of these. But your biggest problems are you need in-house expertise across all these technologies. You also need to manage security patching independently, and security patching can be a mess when you're working with all of these different versions. So I've already talked about some of this on this slide, so I won't go into a bunch of the same detail again, but we're taking all of these and we're merging them together. And not only are we pulling from, keep me honest on this one, guys, all the OpenBMC forks, but we're even taking kernel patches and U-boot patches when those are relevant. We're cherry picking those to try to get ahead of certain issues at the same time. So the commitment to open, again, I kind of talked about some of this as we started, but we are committed to doing an open first code base. And this is our community edition that we host within the OCP ecosystem. Just from AMI's perspective, that is a good place for us to host it, because OCP is kind of that cross section of hyperscalers, hardware vendors, and other people like neoclouds and coming into the community as well. And George just walked in from OCP as well. Glad to have you here at the same time. So we also developed a center of excellence internally to really take a focus on doing better leadership internally, embed certain practices and how we want to do this, and the company's renewed focus on doing open source and improving it as we go. Did we get everything right as we started? No. Are we going to get everything right as we're going forward? No, as well, but we're going to continue to improve, and each time we're getting better at this. We are pretty uniquely positioned across the fragmented OpenBMC industry, working across hardware vendors, silicon providers, and hyperscalers or neoclouds to kind of be a glue to pull some of this together with our manpower and relationships. So we have accelerated our contributions to the Linux Foundation. I've got some statistics coming up, and we're continuing to even accelerate that faster in 2026. We're building teams that are only focused on upstreaming going forward. So what are we contributing beyond this tree? So these are some of our near-term contributions on the left, and on the right, some of our future innovations. So these will go into our open source product to begin with. We've got some protocol support for selective IPMI enhancements, and also some Linux Foundation Redfish enhanced feature support. I know some of those have already started. They're going through the practice right now. We're also doing some media and KVM enhancements. So extended KVM session management, multi-user support, some of the virtual media, so ISO image redirection, and we're also focusing on some of the legacy devices. Now, I know this isn't always the sexiest features that we're talking about here, but some of these are important to the overall community, not always the ones that each individual user is using. We're also trying to do some extensions to OpenBMC tool. So community tool extensions for our community edition specific management. We're also looking at creating a stripped down version of our IDE that we can contribute to the community so that you can have a development studio that's tailored towards BMC development, and also some SBOM integrations. Firmware update. We know that firmware updates continue to be an annoyance to many people in the way they're done. So we're working on some enhancements for multi-device firmware update through PLDM and multi-part update so you can separate some things out. We're also, from some of our requests that we've gotten from some of our customers recently, telemetry continues to be something, and logs that continue to be a better way, or not an annoyance, but can't we do this simpler and fit into my current ecosystems? So as an example, Redfish is great. Redfish does a lot, but some of our customers want Prometheus capabilities so they can scrape telemetry like they do on their other systems. Also, they want FluentBit support to be able to collect their logs together all the same way. So we're going to push these into our open source product. Some extensions for AI infrastructure management. We're going to talk about that in a minute. So OpenBMC is now no longer just running on servers. It's running on CDUs, power shelves, and other things. So how can we help enable the community for this? Embedded SBOM. So how do we embed the SBOM actually into the ROM image so you can pull it out at a later time and review it? DCP SCM plug and play. So this is a specific OCP initiative, but basically in the DCMHS, there is where now you can plug and play your DCSCM into different host boards. So how do you get a tailored image to that platform quickly? Streaming boot. This is also where you're going to allow the BIOS to boot without a physical ROM chip, so you're streaming it at all times, and system config, backup, and restore. So you can see we have a lot of things that we are contributing and planning to contribute as we go through this, and you'll see them kind of get staged somewhat in our community edition and then fully contributed to OpenBMC as we go through the code reviews with them. We might need to make changes. As Patrick talked about, I don't want to say we were the special unique snowflake or the llama as we started contributing to OpenBMC, but we needed to learn how to contribute better and what they were looking for, how to get those through faster. And you'll see that in our statistics that's coming up at the same time. Again, we're not looking to create another fork here. We're looking to create a distribution, and we're trying to pull relevant information from the other repositories for maximum compatibility. So we are also building stronger engagements to OpenBMC. Again, we need to build that trust with the community so they understand that we're trying to be good stewards here. And we have a strong focus on platform testing, versioning that may not always align with how OpenBMC is doing things. Like they may be going to OpenBMC 3.0 next week, but we're looking to version something at the moment. So there's always some of that. At the same time. And also we have a commitment for our code to get yearly testing on OCP safe. So we are going through OCP safe on a yearly cadence. And again, we are committed to upstreaming all of those changes back to the Linux Foundation that's in our community edition, as long as they accept them. Obviously, there might be some things that clash or may not always fit. Here's just an overall graphic, kind of some eye candy about our contribution strategy. You can see some of our leadership positions in the OpenBMC community on the web UI, IPMI, Redfish, KVM, and automated testing, or testing automation, sorry. We've also contributed to a whole group of different core components. Some of the highlights, we're one of the maintainers of the web UI. We do an average monthly contribution of roughly 35 to 40 items. We're trying to participate in the technology steering committee. We are doing the OCP safe, like we just talked about. And we did a security audit also with Eclipsium, who's a firmware security auditor at the same time. So we're doing a lot of these things on the back end, and the community gets full capabilities from that. So here's some of our contributions, some metrics on this. So the red bar is all of our all-time contributions up until 6 months ago, and the blue bar is in the last 6 months in each one of these. So our first contribution to OpenBMC was in 2019, right? So that left-hand bar is really 5 to 6 years of contributions, and the blue bar is the last 6 months. So you can see our last 6 months of contributions is already over 1/3 of our total contributions, and we're doing a lot more there. You can also see our merge changes are definitely increasing. Our in review, those are higher, but that's also because a lot of our old items already got merged in, so it's not really a fair statistic. Total contributors, we've had 55 historically, but in the last 6 months, it's been a focus group of 19. And our qualified contributors, which is a metric that OpenBMC uses to basically judge how your contributors are doing, and then basically you can become a reviewer. There's multi-stages to this. We now have 5 qualified contributors, and we're looking to increase that as we continue to go through this process as well. So again, some of the learning where we move from being llamas to more the cattle of getting the community going, but we're starting to really accelerate this going forward as well. Now, a couple of quick notes on what's the difference between our community edition and our One Tree product on top of that. So One Tree Community Edition, this is the one that we're pushing in open source. It's built for AI cloud scale infrastructure deployment, so it's a thin stack. It's very much based upon the feature set that OpenBMC has. It's a sandbox for experimental features, so this is where we're going to be developing a lot of those experimental items we talked about. Also, it's where we stage a lot of our OpenBMC Linux Foundation contributions. We're moving towards those roadmap items for modern tooling, and we're moving towards also supporting rack management with limited node capabilities at the same time, and also AI infrastructure management. So how does that differ from the One Tree product? This is our hardened stack. So you can consider this more of our LTS stack that's going on over here. It goes through different releases and testing. It's got extensive silicon coverage, so it's got the latest silicon coverage that has NDA features coming from the different silicon vendors. It's got modular and layered architecture for some of these additions. You'll look at a block diagram of it coming up. And it's also used in some OEM type deployments. So when you look at what hyperscalers needs and OEM needs are, they differ pretty drastically. So this is an area that also has a clear differentiation. We also get the security analysis tools, which we'll talk about in a second. And we also have more tools that are more for production line capabilities as well. The expansion packs, the complete AI rack infrastructure, we'll talk about it in a second. But the key thing that you do get under One Tree versus the Community Edition is you sign an SLA so that we are beholden to certain support timelines for fixing issues and providing things to you. So you can consider this our Fedora, and this is our Red Hat versions on the left. Like you can consider it the Ubuntu and the Debian as well. So it's how we're trying to approach those customers who need more help versus those who are doing investment in their internal stack at the same time. We also have devoted a portion of our webpage now to the whole community. You can see it later, but basically this is our One Tree Community Edition website. It's a subdomain of our current AMI.com. I believe it's developers.ami.com. So you'll see this is where we're going to be doing some community news and everything like that. But also, since I know most people in here are developers, you'll live in the GitHub at the same time because that's where we're submitting our actual code patches and such. So just a quick couple notes on what we're doing beyond open source. And this is not a product pitch. I'm more just saying like what differentiates what we're doing here versus there. And also how does the community still benefit from what we're doing in some of the other product areas at the same time. We don't need to go through some of the challenges on open source fragmentation. There's obviously multi-level fragmentation we talked about. Your quality and performance, you really have to take that internally. Interoperability, you want faster deployment, time to market capabilities. You want real-time security fixes. All of these items are kind of challenges. And you have business needs behind that. You still need to have your time to market advantages. You need your own competitive advantage and everything like that. So that's where we kind of plug some of those gaps for those who are looking for more. Now, one of those first areas that we're doing initial investigation and development is AI infrastructure management. So we're still working with some of those initial partners on what the needs are here, but the OpenBMC TAM has expanded now. You're no longer talking about general purpose servers and AI servers. You're putting this on top of rack switches. You're putting it on scale up and scale out switches. You're putting it on power shelves. You're putting it on CDUs. The scope has expanded out pretty far now for where OpenBMC is now. At the same time, the OpenBMC use cases on those devices are very much different than when it was on the server, right? The CDU, you're not going to be reading the same temperatures that you would read on a chip. You're going to be reading the temperature of the actual liquid, and you're going to be controlling flow rates as opposed to fan speeds, these sorts of things. So on top of this, you now need some sort of, for lack of a better word of calling it, orchestration that's getting this all to play well together. And also when it's not playing well together, alert you that something is malfunctioning. So this is where we're working with some of those initial third parties to get this functioning in a stable way. And we'll be pushing some of it out to open source as we start rolling through some of these at the same time. Now, this is where we'll talk about some of our security focus now. So we started with OCP Safe and Eclipsium, but we have a dedicated security compliance team. We also give security advisories to our customers via our customer portal in VMS and SBOM. But you'll see, even though we're doing that as a part of our internal product, all of that filters down to our open source product, which is upstream first at the same time. So you'll still get the advantage of our security fixes and everything else that we're pushing to that. But if you have specific needs of a security or bug that you see in the community, you can report it, we'll work on it. But if you don't have an SLA, there's no guarantee at how quickly we're able to address it more than anything else, because we'll have other customers that are fitting underneath there. Quality and stability, this is where we put through all of our automated testing, and we'll be fixing and going through multi-stage regression testing. We also go through the analysis like Black Duck. Other items in here, we'll go through Coverity. What's the networking testing one as well? Defensics. So we'll go through all of these. Again, all of this ends up is a part of our open source offering. It just filters down from what we're developing internally for that OpenBMC core. And the biggest thing that a lot of our customers see today is the long-term support that they're able to get on this at the same time. If you want to move fast, we offer that. But if you also want to have more stability, we offer that at the same time. And we'll do long-term support of older branches. Here is a stack of just how we view it. So the bottom half here, that is really the Linux Foundation OpenBMC and what we're using across that. That's what is the basis of our community edition. On top of that, we end up with different silicon packs. So the silicon pack is more targeted at a specific host silicon. The BMC SoC is always in that lower layer. So you might have one coming from an Intel, an AMD, an NVIDIA, Ampere, ARM itself. So you'll have that, or you might be a CSP that does your own silicon, these sorts of things. Then on top of that, we also allow AMI expansion packs. So we'll talk about what some examples of those are, but maybe remote debugging or some of these types of features. And then on top of that, we also have the ability that some of our customers develop their own extensions that kind of all build on top of this. So the bottom half, we are pushing out to open source, and those upper portions, sometimes we're restricted on what we can do based upon our partners. Sometimes we're funneling those down over time from our expansion packs. So if we just look at some of the different expansion packs here, there's number one, there's the CRB support, but we are working with the different silicon vendors to figure out how can we make CRBs at least something that is a part of the upstream code base. It will probably happen as we kind of filter some of this down. Then you've also got NVIDIA, and then you've also got AMDs and Amperes below that. So what can we do to be able to better support these types of features? There's a number of features coming here. Some of our expansion packs in general, we've got some autonomous crash dump capabilities, advanced redfish, so more compliant redfish, a whole group of device management and configuration for NICs, NVMEs, NVIDIA GPUs, microchip RAID, Broadcom PCI switch. We've also got some things for memory resilience technology for future analytics. Silicon packs, again, we talked about those from a minute ago, and some advanced features for platform firmware resiliency. So again, some of these were somewhat restricted, sometimes with a silicon partner, sometimes based upon our own release cadence. But why do we work this way? So we're open source based. We want to create a unified code base that's aligned with the whole industry, basically that distro we're talking about, which has production worthy quality with advanced scalable feature sets. So it can scale in multiple ways. You can scale to multiple silicons. You can also scale to number of deployments, scale to different types of devices for CDUs and everything like that. So the whole AI infrastructure rack. We want to be as silicon agnostic and multi-generation as possible so that we can enable our customers' time to market capabilities and release tools that drive some of those efficiency. And using our global resources, we have an SLA-based model behind all of this.